So we're going to slightly shift gears and talk about another aspect of material balances and designing and analyzing chemical processes, and these are reactions. And reactions are really one of the backbones of the chemical industry. We've done a lot with separations, but reactions is another important aspect of the chemical industry. Whether that's a variety of different industries. Fuel production involves reactions where we take raw petroleum or coal or natural gas and we react them to form other chemicals that, for instance, may be fuels for car or fuels for a jet or whatnot. We use reactions in food production. So oftentimes we may take raw material like, for instance, wheat, and we cook the wheat and we react it to form materials like bread or pasta or whatnot, and those are reactions. Pharmaceuticals, if we are producing drugs, we may go through a series of chemical reactions where we start with some chemical and we go through some transformations to get some final chemical that has the desired properties within our bodies. That's the pharmaceuticals. And then let me just mention another one, polymers, where we take raw single unit molecules and we react them with a whole bunch of other molecules and form these polymers. And polymers are just long-chained organic molecules. And to get those polymers formed, we have to get a bunch of small chemical molecules together to react to form these large polymers. And I could keep going on and on and on about the different aspects where reactions are important. They're important in the atmosphere. We leak things into the atmosphere and they react, and sometimes those reactions are not the best that we have in our environment. They might destroy the ozone layer or whatnot, etc. So they occur in environmental reactions or taking place in the ocean, all over the place. Anyways, getting carried away. Reactions are just so exciting. Anyway, reactions are what we're going to study, or this next part, and I want to talk about the concept of a reactor. So we've been talking about flow, and in flow we have something coming into a process and something coming out. And this right here is a reactor. And this reactor essentially enables the reactions to take place. So if I have, for instance, A plus B going to C, for this reaction, I may have some A and B coming in, and then I might have some C coming out. And what would be taking place is this reaction where A and B are flowing at some flow rate. Maybe they're flowing in at moles per hour. And then we have C coming out at moles per hour. And this is essentially a reactor. And there's all sorts of different types of reactors, and we're not going to touch those much in this course. There's a whole course designed in your junior year to touch on reactors that you take and study all this shapes and types and the kinetics and all the different features of a reactor. We just need to know that in this course about mostly about material balances and how we analyze and study material balances, how we keep track of how much A and B reacts to form the product C coming out and at what flow rates they are. And that's really what we're going to touch on for the next part of the course and going on to the next couple weeks as we touch on this, reactors, and other subjects. But I just want to give you a short introduction to reactors and how useful they are.